Okay, so what this is here is a 3 by 2 equation because system, excuse me, because we've got three equations and just two unknowns. Now, generally, if the number of equations is more than the number of unknowns, I might say that the system is overdetermined, and what that would mean is that there are too many conditions for uh, there to be solutions. So generally, again, if the number of equations is more than the number of unknowns, then there is no solution. It's not always true. You can't just look and say it's true. It's just something you should be aware of. You can make a guess as to whether there's going to be a solution or not. Okay. Uh, and I would guess in this case that no, there are no solutions. So we already have a 1 in the upper left. I think this is a pretty short one. Yeah, we already have a 1 in the upper left. So all we have to do is get zeros below the 1. So we'll do that. We're going to add -2 to the second row because there's a 2 that we want to get rid of. So -2 times row 1 to row 2. And we want a 3. We want to get rid of the 3 in row 3. So we're going to take -3 times row 1 and add that to row 3. Okay. And the arithmetic comes out as such, but I encourage you, once again, do it by yourself. Do it yourself. Okay. So now that we've finished that, we're going to ignore the first row, because we already got 1 there. And we will look for the first non-zero column in the bottom 2 rows, which is -1, -5. And so we want the entry at the top, the -1, to be a 1. Now, how can I change it from -1 to a 1? A lot of people like to say divide by -1, but I prefer to think of it as multiplying by -1. So we're going to multiply R2 by -1. Why? Why multiply instead of divide? Because multiplication is in some sense a nicer operation. I don't know. It's a positive one, not a negative sort of operation. But it accomplishes the same thing. Multiplying and dividing by -1 is the same thing. So that's what we get. Now we want zeros above and below the one that we just wrote. So we're going to add, since there's a 2 in the first row, -2 row 2 to row 1. And since there's a -5 in row 3, we're going to add 5 row 2 to row 3. What this gives us is 1, 0, 0, 0, 1, 0, because that's what this algorithm does, -7, 5, and 18. Okay, this bottom row right here tells us that this is bad. This just tells us immediately that there are no solutions. But let's see what I wrote. Erasing, erasing, erasing. This is bad. We're just done. So there are no solutions. What else do I say here? Because of that row. That's why there are no solutions. Let's note that this is not always the case. That more solutions than variables has no solutions. You can have one solution. You can have more equations than variables, unknowns, and you can still end up with any number. You can have any number of equations and unknowns. I don't know what I'm writing here. No, I don't like that. Okay, I guess I just stopped right there. Okay. whatever. I guess the point I was trying to make is this, is if you have more equations than unknowns, you could still have one solution. You can have infinitely many solutions, just probably not. If you have more unknowns than equations, you can have no solutions, you can have infinitely many solutions, although it actually turns out you cannot just have one solution in that case. Yeah, that's pretty much it. Alright.